Welcome to Demystifying Math. In this lesson, we're going to be discussing polar coordinates. Let's start by looking at a polar grid. Normally, when you're looking at a grid and you're plotting points, you're looking at an XY plane. We have an x-axis and a y-axis, and the intersection of the two axes is called the origin. Well, this is very similar. With our horizontal axis, we're going to call it the polar axis, and our vertical axis is the line theta equal pi over 2. The intersection of those two axes is called the pole. Now, what you should also notice is that I have concentric circles coming off of the pole, and each one of those circles has a length of 1 unit longer than the other for its radius length. So the one on the inside here has a radius length of 1, and that's what you're normally used to having called the unit circle. The rest of them are not called unit circles because they don't have a length of the radius to be a unit, but they're still concentric circles, and they keep a lot of the same properties as the unit circle. So what I did was I broke my grid up into angle measures of pi over 12. So each one is pi over 12 units apart, and you can go around the circle and look for some of those special angles that you're used to working with. Now, with a polar grid, the only difference between plotting points on there and plotting points on a rectangular system is that we plot the points in terms of their radius length and an angle measure, rather than an XY ordered pair. But all the points will be in the same position as if they were on an XY plane. Okay, so we're going to go ahead and start plotting some points. So the first point that we're going to plot is the ordered pair 1 and pi over 4, which means that our radius length is 1 and our angle measure is pi over 4. When you plot points on a polar grid, always start by finding your angle measure first. So we're going to go to the pi over 4 line and then go 1 unit away from the pole, and we have our point there. Let's try another one. Suppose that we wanted to plot 3 and 2 pi over 3. Okay, so that means that we want to find the 2 pi over 3 line, so we're going to start at 0, going away from the positive x-axis to 2 pi over 3, and we want to be 3 units away from the pole, so we're going to be at this point here. Let's try another one. Suppose we wanted to plot 4 and 7 pi over 6. Well, you can see that that's on the 7 pi over 6 line, and its 4 circles are 4 units away from the pole. Let's try our next one at 5 and 4 pi over 3. Alright, so we're on our 4 pi over 3 line, and we're 5 circles away from the pole. Now, what would be the difference between that and negative 5 and 4 pi over 3? Well, the negative 5 means that I want to be on the negative side of the pole. So think about each one of these lines that are drawn as being axes as well as the horizontal and vertical axes, where the pole is going to be the difference between having a positive number and a negative number. So if we're at 4 pi over 3 and we want to be on the negative side of the pole, that's actually going to put us on the pi over 3 line. So we're here at this point. So already you can start to see that these points can be labeled in many different ways. For instance, this point, which we just plotted at negative 5 and 4 pi over 3, could also have been positive 5 and pi over 3. So there's lots of different ways to name them. Now look at the relationship between this pi over 3 and 4 pi over 3. They're going to be forming a straight line, which means that we're taking that over pi units. So we could add pi to our angle measure, change our radius to a negative, and get to a point on the other side here. Okay, so let's try another one. Suppose we wanted to be at negative 4 and negative 2 pi over 3. That means that we're going to be on an angle measure that's at negative 2 pi over 3. Well, positive 2 pi over 3 is over here in quadrant 2, which means that we want pi over 2 units and 2/12 more. So 2/12 pi more. So we're going to do the same thing, but we're going to go in the clockwise direction. So we're going to go past pi over 2 and 2 more. That's going to put us on the 4 pi over 3 line. But then we also have a -4, so that's going to put us back over here. Alright, so let's see what happens when we plot that. We're right over here and see this is at 4 on the pi/3 line. So you can see how we got there. Okay, we also have points that we want to be able to plot that are on the axes. So when we're on the horizontal axis, our radius length is 0 because that's going to give us 0 degrees, right? Which is 0 radians. So anything that you want on this line, on this side, would be using an angle measure of 0. If you wanted to be on the other side of that line, you could use pi. So let's say we wanted to plot 4 and pi. That's going to put us on the negative side of the 0 degree angle line, which we could have said something like, let's do -3 so you can actually see it. -3 and 0 is going to be on the pi side of the horizontal axis. To get on the vertical axis, you're going to use pi/2 or 3 pi/2. So let's say we did 4 and pi/2. That's going to put us right on the pi/2 line. And if we did something like 3 and 3 pi/2, that's going to put us on the other side of the pole there. Now the other thing that you want to do is be able to plot points that are at the pole. Well, when you're at the pole, your radius length is 0 because you haven't moved away from the pole at all. And it actually doesn't matter what your angle measure is. Any angle with a radius of 0 is going to put you right at the pole. Okay, enough for plotting points. Let's move on. Alright, so what you saw is that the polar axis is circular and there's many ways to represent any single point on the polar grid. So for instance, if we had that 4 and pi/3, we could also write it as -4 and 4 pi/3. Now remember, the difference between pi/3 and 4 pi/3 is pi units. So we just added pi to our angle and took the opposite of the radius length, which is this formula that we have here. We could also add or subtract 2 pi to our angle measure and get the same point, because that would just be going around the circle one more time. But you can do it infinitely and keep adding 2 pi to your angles. So you're getting all those coterminal angles. So what we want to do here is rewrite the ordered pair 1 and 17 pi/12 in at least 2 other ways. So the first way that I've done it is I took the negative of the radius length and I actually subtracted pi from my angle measure, which gave me 5 pi/12, which is fine. You can add or subtract pi and still get there. And another way that I decided to do it was to subtract 2 pi from my angle measure, and I got -7 pi/12, and I keep my radius length the same. So you have those 2 options and plenty more because you have lots of coterminal angles. Okay, the next thing that we want to do is rewrite coordinates in polar form. Now, when you're in polar form, you need a radius length and an angle measure. When you're in rectangular form, you have an XY ordered pair. So what we've done here is drawn a right triangle going from the origin up to the ordered pair that's given. In this case, we're using the ordered pair 3, 6, and we want to find the polar form for that ordered pair. So when you draw your right triangle, your x value is 3 in this case, and your y value is 6, and we can easily find the radius length by using the Pythagorean theorem. So you know your Pythagorean theorem is a squared plus b squared equals c squared, but the sides of our triangles, or the legs, are x and y, and the hypotenuse is r. So let's go ahead and plug into that formula. So we have 3 squared plus 6 squared equals r squared, which gives us 9 plus 36, or 45. And then we're just going to square root both sides. So we get the square root of 45, and then we're going to simplify that, so we have 3 square roots of 5 is our radius length. Now the other piece of information that we need is the angle measure. And we can get the angle measure by using the tan. The tangent of the angle is going to be the opposite over the adjacent, which is always going to be y over x. That's pretty easy to remember. You could also use the sine or the cosine, but we typically tend to use the tangent because we have x and y already. And we don't have to worry about estimated values. So in this case, the tan is going to equal 6 over 3, which is 2. So then we'll take the inverse tan of that, or the arctan of 2, and we get about 63.4 degrees, or about 1.1 radians. I tend to work more in radians, but you can do everything in degrees as well. Okay, so I approximated the radius length, and the angle measure is 6.7 and 1.107, so that would be our ordered pair in polar form. Let's convert these ordered pairs that are given in rectangular form to polar form. So we have negative square root of 3 over 2 and negative 1/2. That ordered pair should be familiar to you because it is on the unit circle. But let's go ahead and see what happens. So we're going to replace x with the negative square root of 3 over 2 and replace y with negative 1/2 and square both of those. So we get 3/4 plus 1/4, which is 1. And our radius length was 1, which means, yeah, it is on the unit circle. Okay, so now we want to find out what angle measure that is. So you can do the inverse tan of y over x. So our y value is negative 1/2 and our x value is negative square root of 3 over 2. And we're just going to multiply by the reciprocal, and then I rationalize. So I got square root of 3 over 3 for the tan. So your arctan is going to give you pi over 6. But let's think about this for a minute. The ordered pair negative square root of 3 over 2 and negative 1/2 is in quadrant 3, where everything is negative, right? But pi over 6 is an angle that's in quadrant 1. So what we have to do is make an adjustment for this. So you have to find an equivalent angle that is in quadrant 3. So basically what we have to do is add pi to our angle. So our angle is actually going to be 7 pi over 6. So our coordinate is actually 1 and 7 pi over 6. So remember, if you're using the arctan, you're only going to get angles when you use your calculator or anything like that in quadrants 1 and 4. If you wanted anything in the other quadrants, you do have to make an adjustment for those quadrants. So be careful and make sure that your answer is in the correct quadrant. Okay, so in this case, we're going to convert from polar to rectangular, working in the other direction. There's two things you need to know. You need to know that x equals r cosine theta and y equals r times sine theta. So we're taking the ordered pair 3 and 7 pi over 4, and what we're going to do is find x, which is 3 times the cosine of the angle, 3 being our radius length and 7 pi over 4 being our angle. Now with 7 pi over 4, your cosine is going to be square root of 2 over 2. So we're going to multiply that by 3. So we have 3 square roots of 2 over 2. And with the sine of 7 pi over 4, you have a negative square root of 2 over 2. And then multiplying by that by 3, you have negative 3 square roots of 2 over 2. So you get your rectangular form of the ordered pair. Let's try another one. We have 4 and negative pi over 3. Now looking at 4 and negative pi over 3, that's going to be in quadrant 4. So you should know that your ordered pair is going to be a positive x value and a negative y value. So 4 times the cosine of negative pi over 3 is going to be 4 times a half, or 2. And for the sine of negative pi over 3, we get negative square root of 3 over 2. And multiplying that by 4 and simplifying, we get negative 2 square roots of 3. So in rectangular form, you have 2 comma negative 2 square roots of 3. Okay, thank you for tuning in to Demystifying Math.